Hello and welcome back to another episode of Wilson Center Now. I'm John Molesky. Today we're going to be talking about the red hot summer of 2023, which has spilled over into a hot fall, and talk about maybe the difference between climate change and weather. And joining us for the discussion is Lauren Herzer Risi, who is director of the Wilson Center's Environmental Change and Security Program, and Matthew Huber. Matthew is a professor with Purdue University's Department of Earth, Atmospheric, and Planetary Sciences, where he directs the Institute for a Sustainable Future. Welcome to both of you. Thanks for joining us.
Yeah, thank you very much.
So this has been on the books for a couple of weeks. And as I've anticipated speaking to you about it, Matt, I kept checking the headlines to see what would be if we had done this about a week ago, we might have been talking about flooding in New York that was making Brooklyn look like New Atlantis instead of New York. Today, I wake up to a BBC headline that maybe both of you have seen. It was warmest September on record as gobsmacking data shocks scientists. And the gobsmacking reference comes from a climate scientist by the name of Zeke Housefather, who had a tweet that said, or the X formerly known as tweet, "This month was, in my professional opinion as a climate scientist, absolutely gobsmackingly bananas, the warmest on record." I'm just wondering, at what point do we stop talking about extreme weather and just call it weather, the new normal? Matt, could we begin with you?
Sure. Yeah. Well, I think that one has to accept the fact that climate represents averages over long periods of time of both kind of typical weather and averages of extreme weather. And as climate change is happening, the extremes are becoming more extreme. So it's absolutely true that we just have to get used to these new conditions, but that doesn't actually make them better somehow. It's like getting bitten by a dog. I mean, if you get bitten by a dog every day, it doesn't make it any better. So yeah, I think that we need to be thinking about adaptation and we need to be thinking about building resilience. But we shouldn't just accept this as something to get over either.
Yeah. Lauren, I wonder, one of the things that I've always complimented you and ECSP on over the years is that you're always been ahead of the curve on these discussions, ignoring the sort of passion of the politics that sometimes engulf these scientific issues, focusing on the facts and looking long term and thinking about those things that Matt just talked about, like adaptation and resilience. I'm wondering how this increase in extreme weather events is affecting the way that ECSP approaches its work. Is it changing the way that you look at things?
I mean, I think one of the things that strikes me is that how we've talked about the threat of climate change over the last 30, 20, 10 years. We've been talking about this threat, but now it's here, right? And so we are actually experiencing the impacts of climate change all over the globe. And the headlines are bleak, and they also point to how diverse those impacts are and how they interact with different vulnerabilities in different contexts and how different communities are impacted differently, right? And so as we think about our climate responses, understanding that investments need to be made in targeted ways that sort of build on the sort of resilience capabilities of communities on the ground, respond to the risks as they're experiencing them, right? So that means more engagement at the local level between sort of the high levels of decision making all the way down to the ground, being able to incorporate local perspectives. And then also recognizing that in our responses to climate change, if we're not going forward with our eyes wide open, there's a potential to introduce unintended consequences, right? So we want to, the renewable energy transition is going to demand an immense number of critical minerals, right? And those minerals are often located in places that have weak or unenforced environmental and social safeguards. So how can we sort of access those minerals in ways that don't bring harm to the local communities, and hopefully actually, increase their own resilience. So it's this integrated way of thinking across systems, and it requires a sort of a shift in how we think about our relationships with other communities and with other countries, and how we think about how we respond to crises, both in the short term and the long term.
Thanks. Matt, is there a way to contextualize for us sort of where we stand in terms of the projections that we've been hearing for a long time about worst case scenarios, or where this is all potentially headed, to where we are on that scale at this moment? It seems as if Lauren just said, we're past talking about what might happen, and now we're living with what is happening.
Yeah. So I think there's two important points there. So first, I just wanted to follow up on what Lauren just said. So, I can talk about it from my own personal perspective. So, once upon a time, I was director of the Purdue Climate Change Research Center, and we were focused on climate change and its impacts. And now I'm director of an Institute for a Sustainable Future. And that change just in how it was framed locally mirrors the change in framing that's happened internationally. So you can't think about climate change without also thinking about critical materials, and thinking about humans on the ground and the health impacts, and how economies and societies will respond not just to climate change, but to efforts to deal with climate change. This is a complex problem. I hesitate to use words like wicked and super wicked, because that just makes it sound so complicated we don't even bother solving it. No, you have to embrace the complexity. You have to get better at dealing with trade-offs, dealing with compensation, and dealing with the feedbacks of society onto climate change, and from climate change onto society. So if you embrace the complexity, you can see that there are solutions that can be deployed, but they are rarely simple or move forward in a linear fashion. So I think we've gotten much better over the years at realizing the problem is not just climate change, the problem is people. So that was the first point. And more directly following up on your question, when I first started this, when I was a young and eager 19-year-old at the University of Chicago, I was watching talks given in the geophysics department on the fact that climate change might happen, and probably would happen, but it was kind of debatable how big it would be. And there was so much uncertainty. Kind of uncertainty was the word that was thrown around really for 20 years. And uncertainty is never your friend. It's never your friend in the decision-making process, certainly. But on the other hand, if uncertainty can be beaten down to a certain level, you don't have to worry about it so much in terms of your decision-making. So we now know enough about the climate system to know that we are causing it. The changes are going to be large. They're probably going to be both larger and faster than what climate models have tended to predict. And we've known about this, depending on how far you want to go back. We've known the theory for more than 100 years, and climate models have been predicting this since the 70s or 80s. So, the time is absolutely now to move forward in a number of directions. Obviously, reducing CO2 emissions is the number one thing that we need to focus on, but we can't just focus on that. We have to be building out the resilience tools and adaptation tools at the same time.
A disconnect that occurs to me as a layperson and a bit of a math idiot is that when you look at the numbers, when you as a non-scientist, and you see that small differences, small shifts can equal huge outcomes, and I think that creates somewhat a level of confusion among the non-scientist who looks and says, well, a degree or two, how much can that matter?
Well, sometimes people think of themselves as math idiots, but on the other hand, if you just look at the change in interest rates, right? All that's happened in the past X number of years is relatively small change in interest rates, and that's sufficient to completely change people's experience of the economy, go from low interest rates and people buying homes left and right to all of a sudden whole sectors of the economy slowing down and Americans becoming less mobile because they can no longer afford to buy and sell homes, and tanking the stock market. I mean, just changing something a couple of percent can completely change the global economy and people's experience of the economy. Well, if you think about CO2, I mean, we're getting close to having doubled it, right? So, we're not talking about a couple percent change. We're talking about nearly doubling the amount of CO2. So it's probably not useful to think of these as small numbers. The question is, small compared to what? There are some systems that are highly geared. The climate system is highly geared. It has strong positive feedbacks, and things that seem small can propagate through the whole system, just like a 1% change in an interest rate can propagate through the global economy very quickly.
Yeah, it changes 1% interest rate changes thousands of dollars or more of what you might owe on a mortgage or something like that. Lauren, over to you. Your thoughts or questions for Matt?
Yeah, I think, one question for you, Matt, is we've seen reporting on climate change expand dramatically in recent years, right? And for good reasons. And I'm curious from your perspective, what you wish we were seeing more of in that reporting on climate change. Like how could we communicate to the public more effectively sort of the complexity behind climate change, but then also the opportunity to respond better?
Yeah, so I think that there's a lot of both sidisms. So 80, 90, 98% of people who are knowledgeable about the topic of climate change think a certain set of things are true, but in the interest of balance, the media tends to find the one contrarian and highlights their position as though it was equally likely to be true. That's something that is probably not useful and doesn't accurately convey the science. So I think that's definitely one thing that could be changed. But I would also say that a key message from my point of view that really could be gotten across better is that one of the key uncertainties in climate change is the so-called climate sensitivity. So how much does global temperature change as the amount of CO2 or greenhouse gas forcing changes? So that's often portrayed as this huge uncertainty and means that we can't know anything about the future. But we now know enough about how sensitive the climate system is to CO2 to know that we have to do something, and we have to do it now. That's a change that's happened in the past 10 years. Our uncertainty on that number used to be big enough that it was kind of like, could we wait 10 years before reducing emissions or no? Now there's no question. And I think getting that point across better would be ideal, that we absolutely know enough to start reducing emissions globally right now and very quickly, and that there's really nothing that should be preventing us in terms of sober thinking from doing that.
Go ahead, Lauren.
Matt, can I ask you a follow-up question on, I think one of the things that you have contributed to our understanding that I think is fairly significant is that idea of a wet bulb temperature. Could you explain what that is and its significance?
Yeah, absolutely. So you can think of wet bulb temperature as the temperature that your skin would be able to reach in the absence of any other kind of heating. So you lose most of your heat, about 80%, 90% of your heat, through sweating. So wet bulb temperature is the temperature of a moist cloth, like a wick or a wet sock. And just imagine taking a regular thermometer and wrapping a wet sock around it and spinning it around your head. And if you kept that up, that thermometer would cool evaporatively to a certain temperature. So that's called the wet bulb temperature. It's literally a wet bulb. And that maximally evaporatively cooled temperature is much colder than the air temperature around you. And you can think of that as the coldest your skin could possibly get if you were evaporating your heat in that way. So that sets a limit for your own relationship to the environment around you. So each one of us is sitting here generating heat. I'm burning up the cereal that I ate this morning, which means I'm generating about 80 watts of energy that I have to be able to lose through my skin. Otherwise, I would just sort of slowly cook myself. And if I can't lose heat through evaporation, then I will absolutely have some sort of heat stress problem. And so that wet bulb temperature has to be sufficiently cool to allow me to lose heat through my skin. Your internal body temperature is about 37 degrees C. If the wet bulb temperature is near that value, then there's just really no way for you to lose your heat.
And do we have a sense of what is the temperature on that thermometer before you put it inside the wet sock that it reaches the level where your body cannot adapt quickly enough, and all of the negative health impacts of heat stress start to
yeah, well, it's a combination of temperature. It's a combination of temperature and humidity. So, simple example would be 37 degrees C and 100% relative humidity would be enough to cause you serious problems if you sat under those conditions for a long period of time. But actually, it's a combination of temperature and humidity. And in a paper that we have coming out next week in the Proceedings of the National Academy of Science, we've revisited the wet bulb limit that I originally proposed in 2010 in a paper led by Dan Viselio. We have an empirically derived limit, which was derived by putting actual people in relatively warm rooms and humid rooms and seeing what their body's response to it was. And that temperature limit's substantially lower. It's not 37 or 35 or 34 as we had originally proposed. It's more like 31 degrees wet bulb temperature, which effectively means that if global warming is more than 2 degrees C, large parts of the world start experiencing this very dangerous kind of wet bulb temperature relatively once a year or a couple days or up to couple weeks a year at more than 2 degrees C.
Is what we saw in Arizona, parts of Nevada this summer, where there was this tremendous heat wave over the course of weeks. Is that an example of what we're talking about here?
Well, yes and no. So in some places, you get in those regions, you get a moist and hot condition, but the vast majority of the time in the Southwest, what you're looking at is a hot and dry condition. So provided you're drinking enough water and you're well ventilated and you're an otherwise healthy person, you could hypothetically be able to deal with dry heat pretty well. And indeed, you can get people who run marathons in Death Valley on a hot day, but it's not recommended, especially if you're not drinking enough water and you don't have a fan and you're not healthy. Then obviously there's a huge number of problems that can kick in. What's of concern to me is that people think that heat stress only happens when it's hot and dry. And that's why I'm constantly pushing for really thinking hard about other means of estimating heat stress that include the effect of moisture. So basically, if you can't sweat away your heat, you have a problem. And then the best way to deal with it is something like air conditioning.
And that introduces its own problems on climate change, even though it might help the individual in the moment. Matt, I'm wondering, what are the countries or areas that are most feeling the brunt of the types of things that we're talking about as it relates to heat stress?
Yeah, well, unfortunately, they also tend to be the most populous countries. So relatively small change causes a disproportionate change in a population-weighted sense. So those countries include India, Pakistan, Bangladesh, various other regions within Southeast Asia, China, West Africa. There's a whole band across West Africa where this is an issue. Also the Gulf Coast of the US, the coastal regions in the Middle East. So, really anywhere where you have warm water near hot land, you have a potential for a problem. And in a population weighted sense, this is a huge challenge, and it raises the threat of what is already happening, which is widespread reductions in the ability to do labor on hot days, which affects economies and affects the ability of people to make a living. But as that gets worse, and there is really no way for it not to get worse if climate change continues in the direction that it's been going, you just get these hot, wet days expanding in geographic area, expanding in duration, and you really won't be able to escape them. And these are some of the most populous, most densely populated places on Earth.
And Lauren, I know that you and the Wilson Center writ large have done a lot of work on climate refugees, and that certainly is, if you play this out, what Matt's just describing, that's where we're headed, right? Where big chunks of the globe become less habitable, if not uninhabitable. And what happens? Where do people go?
Yeah, I think sorry, go ahead, Matt.
I was just going to say, I try to not use the word uninhabitable, because, if we were so strictly determined only by climate, then, Sweden would be uninhabitable, right?
Yeah.
So obviously we can build infrastructure, we can design better societies that are resilient to weather extremes. But I also totally agree that to do that involves infrastructure, and it involves change, and so we have to make it continue to be habitable. So,
I appreciate you saving me and our viewers from my hyperbole, Matt. So thank you.
sorry to interrupt.
No, not at all.
Well, I would just add that, I mean, we are seeing the impact of climate change on people's decision to move. We steer away from sort of the idea of a climate refugee, since there are still not any legal status for people who have been displaced by climate. But more and more, we're seeing people impacted by extreme weather events. We're seeing their livelihoods sort of undone by impacts on agriculture, whether it's through drought or sort of invasive species, right, moving into different temperate zones. But those impacts interact, going back to some of what Matt was talking about, with the existing sort of demographic, social, economic, other environmental factors that are at play on the ground. And so understanding that complexity of climate change, how it's interacting with different aspects of people's sort of lived experience also provides us a better way to identify where those entry points are for having a more effective response. So if we can stop thinking about climate change as this like thing that's happening and think of it more as the context in which all of these other things are also happening, then it opens sort of the toolbox, right, of where there are opportunities to respond more effectively.
I want to follow up on that in a second, but we're getting short on time, so I want to give you an opportunity, Lauren, if you have any other questions for Matt before we move to sort of a final segment.
No, I would just ask what I always ask, which is, where do you think we need to be sort of putting our investments for the most meaningful and effective responses to climate change?
And there you go. That cues up the final segment. I'm going to ask both of you, where do we go from here? We've laid out a scenario. Matt, your whole institute is looking at this question of what a sustainable future might look like.
So I would say that where I would focus a lot of attention would be at the poverty line. So we've done some work where we analyzed globally, but specifically with fine detail in West Africa, is heat stress going to have a major impact for people at the poverty line? So like roughly people who are living on less than $1 a day. And what we found is a massive increase in the number of people who are moved into poverty just due to the effects on the ability to do labor of heat stress. So not including the health impacts, not including a whole variety of other things, but just not being able to work hard puts a large number of people into poverty in West Africa with relatively modest amounts of warming. And I would think about that globally, not just how is it going to affect people like me, right? But people who are already, they're struggling to get out of poverty, and right now they're successful. Right now, the tailwinds of the economy perhaps are helping them, and they're working hard. So how do we make sure they don't backslide and end up pushed back into poverty by climate change? And I think that's a very important place for us to be focusing our attention. And that's right where all of these other factors come into play. So what is the economic setting? What is the social setting? What is the educational setting for people in these positions? And as long as we're providing hope and opportunity and benefits and moving people out of poverty, I think the people benefit, global society benefits, and we're all winners. But unfortunately, that's what climate change and heat stress is really going to do, is it's going to knock people down a notch. And if you're right at the poverty line and you get knocked down, this is a place where it is destabilizing and potentially, a major risk.
Well, there's always so much more to talk about, but I think that sobering and challenging thought is a good place to end it, because it's certainly where the rubber meets the road, right? What's happening to people, the most vulnerable people on the planet. Lauren Herzer Risi, Dr. Matthew Huber, thank you very much for joining us today and for this discussion.
Thank you very much.
Thank you, John. Thank you, Matt.
We hope you enjoyed it and that you'll join us again soon for another edition of Wilson Center Now. Until then, for all of us at the center, I'm John Molesky. Thank you for your time and interest.